In our example, we have seen that promotional budget and number of passengers are highly correlated. If we spend, you can see this promotional budget as simply ticket fare. Like if we give lot of offers on ticket fare, the passengers are high. If we give less offers on ticket fare, the passengers are low. Now, from there, can we estimate the number of passengers given the budget? Generally, that is the usual intuitive question. If we know that promotional budget and number of passengers are highly correlated, the first question that we ask is, what about spending this much of amount of money to achieve, and what will be the number of passengers? So that is the usual question that we can ask. Like, can we estimate the number of passengers given the budget in a particular week? Can we use correlation for doing the same? Now, correlation is just a measure of association. It can't be used for prediction. Correlation, given two variables x and y, it can tell us to what extent they are associated, to what extent they both are correlated with each other. But correlation can't tell, given one variable, what is the estimated value of the other variable. In our 8 passenger example, given the promotional budget, we can't simply get an estimate of value of passengers. For that particular problem, we need a model, we need an equation, a fit, a curve fit for our data. So that model, that equation is known as regression line. So what is the idea of regression? Correlation just measures the degree or strength of association. It just quantifies the association between two variables. Whereas it can't tell, given one variable value, though they both are highly correlated, correlation can't give us an estimate of second variable given the first variable. So what is regression? A regression line is a mathematical formula that quantifies the general relation between two variables. One of them is predictor, the other one is target or dependent variable. So number of passengers depend on budget, promotional budget. So promotional budget is the predictor variable that predicts the number of passengers, or the target variable, or number of passengers is the dependent variable. Number of passengers depend on promotional budget. Promotional budget is independent. It doesn't depend on anything. It is the one that we spend upon. We don't need to look at anything else. Whereas depending on promotional budget, number of passengers change. So here is the regression line. If we have x and y, we can simply write y equal to beta naught plus beta 1x. Why we have to write like this, we will try to see in next few topics. So what is the best fit up for our data? What is the best line that goes through our data, or what is the best line that goes through the core of the data? So here is a simple example where you have x on your x-axis, y on your y-axis. Now this is the relation between x and y. Let us suppose this is the data. Okay. Now looks like there is a high correlation between x and y, or there is high correlation between x and y, let's say 95%. Now what we want to do is, given the variable x, what is the value of, or specific value of x, what is the value of y? Let me tell you, let's say what is the value of y when x is 30. Just look at this graph. Tell me the value of y when x is 30. So are you imagining a imaginary line that will go through this data, and are you telling me that y is 40 when x is 30? What did you do? You have imagined a line that passes through the core of the data. You have kind of drawn a straight line that will go through this data, and you started at x, you went up till there. So there are so many lines in this data, but you started at, you have imagined this line, you started at x30, and then you went till this point. Wherever it cuts, y would be in and around 40. That is how you have estimated. That imaginary line, that line that represents our data, that line with the least error that we thought, is called regression line. We just intuitively fit a regression line for our data. Now mathematically or statistically finding the regression line we are going to see in next few slides. But this line that represents that formulate the relation between x and y is called regression line. Y is the target variable, it depends on x. So regression line fitting using least squares estimation. So how do we fit it in a theoretically correct manner? Okay. So let's try to understand this regression line fitting. Let us suppose these blue dots are the data points. 1, 2, 3, 4, 5, 6 data points are there. Now what we are trying to do is we are trying to fit a regression line for this data. On the x-axis and y-axis you have two variables. So this regression line equation or any straight line equation is y equal to beta naught plus beta 1 x. When we are saying that I want to fit a line, we are trying to fit a line, we are trying to fit a straight line, that is y equal to beta naught plus beta 1 x, whereas we are simply trying to find beta naught and beta 1, that's it. When we say I have fit a line, that means we found beta naught and beta 1, that's it. So we are trying to fit this green line, that is the regression line, which is the best fit for our data. So what are we trying to do? We will first imagine this line and we think that this is the one that minimizes all the errors, but still there are some errors. At this point, if you see x, if you predict, the line will be predicted as this one, whereas the actual value is this blue dot. So epsilon 2 or epsilon I is the error at this point. Similarly, there are so many errors, error at each point. These are the errors at each point. So this is the actual data with regression line, imaginary regression line. This is regression line and then just errors. So there are some positive errors, there are some negative errors. Some errors are in blue, some errors are in black. Now the line that minimizes all these errors together is the best line, right? The best fit will have the least error. Now if we simply find the sum of these errors, sum of error 1, error 2, error 3, error 4, then we will be ending up at almost like near zero error. Why? Because there are some errors that are positive, there are some errors that are negative. So directly simply taking the sum of the errors won't work. So we need to first square these errors and find the sum of squares of errors. Then try to minimize the sum of squares of error. So we will try to find a regression line that will minimize the sum of the squares of the errors. That is why it is called least squares estimation. So you have the data, x values and y values. We will imagine a line through all the points and we'll find the deviation at each point. That is called residual or error or the deviation. We square up that deviation and we will find out the straight line or the regression line, or we will find out the values of beta naught and beta 1 in such a way that we will minimize the sum of the squares of the errors. So what is the error? Actual, y actual minus y predicted. Y predicted is nothing but the regression line beta naught plus beta 1 x whole square. So this using calculus we can simply minimize this function, find the values of beta naught and beta 1 so that they will minimize this function. This is nothing but the sum of squares of error function. So the regression coefficients that we are getting at the end of the line fitting, beta naught and beta 1, they are the best possible values that will minimize the sum of squares of errors. This is called least squares estimation. This is how regression line is fit. Let us do an example. We don't need to do all this least square line fitting manually. R has a package inside it. We can just use the package. Finally, what are we expecting? Line fitting. We are expecting beta naught and beta 1 values. So R will take care of all these least square estimation and finally present us with beta naught and beta 1 values. So simply we can use those beta naught and beta 1 values.